So arene oxides. What are arene oxides? Well, I told you they're very similar to epoxides, right? So here's the difference. In the previous videos, we've talked about these ring structures, and these ring structures could have had an epoxide group on them. We treated these just like normal. It was like another day. They did epoxide reactions. You know, no questions were really asked here. However, here's the thing. Arene oxides are very similar, but arene oxides have double bonds on the inside. So meaning that what was here before was a delocalized network. Do you see that? Double, single, double, single, double, single. Double, single, double gives you trouble. These are delocalized systems. And there is a chance that this delocalized system breaks the double bond in the delocalized network, and folks, it opens up a epoxide ring that could form there. Well, this oxygen has some free sets of electrons on it. But the issue here is that the delocalized network is very unstable compared to what it was, because here we do see a double, single, double. But the molecule knows that if it can get rid of this epoxide group, and if it can replace that epoxide group with that double bond, it really is delocalized all the way throughout the system, and right now it is not. It's too far away. Remember, they have to be alternating carbons in order to do this, and right now that's not the setup. So here we see a case of an epoxide. That epoxide is on a ring just like before, but the difference is that this was very close in becoming a delocalized ring that we called benzene. So benzene, here we go, here's the structure of benzene, can be changed to an epoxide that we call an arene oxide with the use of what we call Cytochrome P450 and a little bit of oxygen. Well, what does this even mean? Why should I even be paranoid over this? Here's why, okay? The Cytochrome P450 is inside of your body. This is an enzyme, and that enzyme does a specific purpose. And one of the purposes is that it takes something like benzene and it converts it. Okay, well, why do you do that? Well, benzene's very poisonous. Benzene is a molecule that we do not want in our system. So if our body can destroy it, then maybe, just maybe, we can get rid of it, and that benzene structure is not going to be devastating to us. And that requires a little bit of O2. Where do you think the O2 is coming from? Yeah, that's right. You breathe that in. So O2 and Cytochrome P450 is an internal reaction that's happening here. So this arene oxide is very much like an epoxide. They start out with benzene rings. The reaction happens. It cleaves one of the double bonds in the ring, and an epoxide forms at that location, and that's what we're seeing right here. This can undergo epoxide reactions, just like the acid reactions, just like the base reactions that we've talked about. And that means that if any aromatic compound, like benzene, enters into the human body, it's going to recognize it as a foreign object, and the arene oxide is going to be formed. Where do we get benzene? I mean, I'm not walking around with a bottle of benzene at my house. I know you're not. I hope you're not. There's benzene in your gasoline. When you pull up at the gas tank and you pump that nozzle into your gas tank and smell the wonderful fumes of the gas that's coming from the nozzle, you're breathing in benzene, possibly pure benzene compounds as that's happening. But benzene-related compounds can also come from cigarette smoke. Benzene-related compounds can also come from charcoal. You're not a smoker? That's not a problem. You like to cook out using charcoal briquettes? Well, you have a chance of taking this benzene-related compounds and forming them into these arene oxides that then will go into your system. The epoxide makes this molecule more water soluble. That's another problem because we're water-based creatures. So in these reactions, we typically see the epoxide break, just like what we would expect. And this epoxide, which side it breaks on, it doesn't really matter, but this epoxide will break open, and oxygen will typically get a hydrogen, just like it always has. And then on the other carbon, we typically get some type of group, whatever group that might be. I'm just going to put Y there because that's normally what we do for nucleophiles. If we don't write NU and we write a Y instead, that's nucleophile. So these benzene reactions, our first benzene reaction, can take place in the body. And these benzene-related compounds come from normal everyday things. And that Cytochrome P450 with O2 will convert those benzene-related reagents into an epoxide that we call an arene oxide, and then that epoxide can eventually break down and become reactive. The issue here is that arene oxides, this stuff, folks, this stuff is highly carcinogenic. That means it causes cancer. So maybe not the reagent. Whatever benzene-related compounds are over here on the left-hand side, maybe these are okay. Now, benzene is not, but benzene-related compounds could be safer, and they are. Many of them are. And it's not necessarily those reagents that cause cancer. But what happens is that these compounds get absorbed into the human body, and your body produces these products that are arene oxides. And when the arene oxides begin to build up and begin to happen inside of you, folks, that's the bad news compound. Those arene oxides are highly carcinogenic. Now, not all of them cause cancer, but many of them do. And one of the most common that's out there, that's the most problematic, is something called benzo bracket A bracket pyrene. Benzo A pyrene. It is one of the most aromatic carcinogenic compounds known. That comes from cigarette smoke, and that also comes from charcoal briquettes. Now, the story with charcoal. Oh no, my 4th of July is ruined. My grill, my charcoal grill, I'm going to get rid of it. I need the natural gas, the propane gas one. No. There's a funny thing that happens with charcoal. Only meat eaters need to be worried. What? That's right. If you're a vegetarian and you put a nice grilled pineapple, and I know this might sound weird, but grilled watermelon onto the grill, or grilled veggies like corn on the cob, grilled squash and zucchini, any of those fruits, any of those vegetables are A-okay. We're talking about hamburger meat. We're talking about chicken. We're talking about pork. And that's because people do not know how to use a charcoal grill the proper way. Okay, what does he mean? I just light the charcoal briquettes up down here at the bottom and I set it on fire. Whoosh, there it goes, right? Kinda. So up here on top, that's probably your grill slat. And then on that grill slat, you probably have a nice big old chunk of steak or hamburger patty or something. The issue is the protein that's in the meat. The proteins in the meat react with the carbon-based briquettes on an open flame, and they produce these benzene-related compounds that get turned into the benzoapyrene. That is where the misinterpretation of charcoal grilling comes in. If you use the charcoal briquettes the right way, you do not have a problem. Well, how do you use them the right way? You light them on fire. You allow them to burn out. You do not want an open flame here. It's the flame, folks, that causes the problem, not the charcoal briquettes. So as the charcoal goes out flame-wise, you're still going to get the residual heat that comes from the briquettes. That heat is what needs to cook your food, not the flame. You do not know how many times I have seen people to light up a charcoal grill, and they do not wait for the flames to go out before they put the meat on the grill. That is not how you use a charcoal grill the proper way. That will cause benzoapyrene. That will cause carcinogenic compounds to basically be engulfed and absorbed by your body. Again, only meat products, though. Fruits and veggies are okay. It's the protein in the meat that causes the problem. So the next time you use a charcoal grill, put your charcoal briquettes in, light them on fire, clean off that grill slat, let the fire flame go out, and then that residual heat is what needs to cook your meat. If that is okay and you are not getting flames that shoot up through the grill slats when you put your meat on there, then you are perfectly fine. Nothing bad or nasty is going to happen. But if you don't follow those steps, folks, you could be eating and engulfing carcinogenic compounds and you've just never known it. It's as bad, if not worse, than cigarette smoke. These arene oxides, the problem with them is that they begin to bond with the DNA. Your body, of course, has DNA. That is what makes you who you are. And if you look at the arene oxides, here is an arene oxide compound, and there is a nitrogen off of these bases that are involved in the DNA strand. These bases are typically labeled as A, T, G, or C if you've had a biology class. So these nitrogens, free pairs of electrons, that is a nucleophile. That nucleophile sees a carbon that's involved in the arene oxide that's more exposed, partially charged carbon that's positive. And then that opens up the arene oxide molecule. And folks, look at this. We now have a modification of the DNA base. And this is very problematic. And this is what leads to the mutations and modifications of the DNA strand. And once that DNA gets warped or mutated in such a way, then this could cause cells not to die. And that's really what cancer is. The cells do not know how to self-destruct, so they just keep growing and growing and growing, and before you know it, a tumor begins to happen, and hopefully that tumor can be removed and no more growth is going to happen because you've removed the affected area. But this is the start of something that's carcinogenic. It's all about DNA. It's all about modifying that strand, and this triggers the cells not to die from that point. All right, so that's my story with arene oxides. So I think now what we can say is that we are pretty much finished with alcohols. We're finished with ethers. We're finished with epoxides. So we've got 2 more sections to go. I know, this seems like it's the never-ending story. One of a great movie, by the way, back in the 80s, if you grew up. But it's a never-ending story of reaction, reaction, reaction. And again, I told you this was the problem. In the very beginning of this lecture series, I told you it's an onslaught of reactions. And I hate that the semester starts off this way, but that's just the way that it is. So just bear with it, get through it, and you're going to see that the other modules are not quite as bad. At least they're more coherent and tied together, not just random stuff dumped into a chapter and said, here you go. okay? But we know they're really not random, are they? Alcohols need protonation. Ethers need protonation. Epoxides need protonation. So what about amines and what about sulfurs? Well, you're going to find that out in the upcoming lecture videos.